here we also have, now that we got more transcendental functions, we have the cosine still, but not the trig, but now we have this e right there. What the heck? Okay, so the new transcendental functions on top of the trigonometric transcendental functions, you have the derivative of e to the x. This is the coolest function ever. You know what the derivative of e to the x is? E to the x. It's the same thing. And you're thinking like, what? Yeah, the weird part is like, if you look at this function, e to the x, every y value that is on this function, if you were to draw a tangent line, the y value of that point right there, the y value is the slope. I know, it's weird. I think that's super rad. And then the one that's not in this problem, but it's related to e to the x, is the derivative of natural log of x. The derivative of natural log of x is 1 over x. Okay, so 2 quick little facts that you guys should know. Now, let's do this, okay? We have the derivative of sine, and he's multiplying to 7. Now, if you are paying attention, you know that we just looked at the product rule yesterday, and you might be thinking, yo, Mr. Patey, you have 2 things multiplying to each other, so let's use the product rule. The crazy thing is you don't need to do that here. You can, it wouldn't be wrong, but you don't need to, and I'll tell you guys why really quick. If you take the derivative of 7, what do you get? Product rule says you would take the derivative and you would multiply it times the other function, which in this case is cosine x, and then you would add 7 times the derivative of the other function, and the other function is cosine, so the derivative of that would be negative sine x. And what do you get? Well, this goes away because anything times 0 is 0, and I'm left with negative 7 sine x. So you don't have to do the product rule when one of the functions is a constant. Okay, now back to this. All right, what is the derivative of cosine? Negative sine. You take the scalar, that's what they call it. You could take him out, and you can say, I'll deal with you later. And then you take the derivative of cosine, and you're like, all right, I got negative sine x. And then the scalar comes in and goes, oh yeah, and it changes them, makes them into negative 7 sine x. And then you have one more. You have the new and actually quite pretty 3e to the x. What is the derivative of e to the x? Yeah, again, you can ignore the 3 for a minute. Take the derivative of e to the x, you get e to the x, and the 3 comes back in and goes, whoop-ah! Multiply it to e to the x, and that's your answer. All right, look, the natural log, he made his appearance. There he is. So we're going to take the derivative of this guy, ignoring the scalar until after we take our derivative, and then we're also going to take the derivative of this guy. He has no scalar. Aw, everybody say, aw. Oh, you guys are like, oh, my grade. No, I'm kidding. What is the derivative of natural log of x, dudes? 1 over x. So if you had 5 times 1 over x, what is that? It's 5 over x. You can make the 5 into a fraction if you want, so it'll help you see that you just multiply straight across the 5 and the 1 and the 1 and the x on the bottom. And then I'm going to go minus sine x. That's because the derivative of cosine is negative sine x. And that's it. That's done.